رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to start lecture number 7, which is about the measuring instruments. Before going to start our lecture, I would like to share a quotation with you. Small steps in the right direction can turn out to be the biggest step of your life. Vernier calipers is an instrument which is used to measure the length of the small objects which are less than 10 cm in length. It was invented by the French physicist Vernier. Vernier caliper consists of the main scale with one fixed jaw, and the main scale is calibrated in terms of the inches, in terms of the centimeter, and also the millimeter lines are drawn on the main scale. It also consists of the movable vernier scale on which 10 small lines are also given, or we can say that it consists of the 10 divisions. Vernier caliper also consists of the external jaws which are used to measure the external diameter of the objects, such as the diameter of the ball or the diameter of the cylinder. Internal or upper jaws are also given, which are used to measure the internal diameter of the cylinder or internal diameter of the object. It also consists of the tail given at the back side of the vernier caliper, and the tail of the vernier caliper is used to measure the depth of the given object, such as the depth of the cylinder. Now we will discuss about the least count of the vernier caliper. Main scale and the vernier scale is given here in the figure. The smallest division which we can measure with the help of the vernier caliper is 1 millimeter, while the vernier scale is divided into 10 divisions. So we can find out the least count of the vernier caliper as it equals to the smallest reading on the main scale divided by the number of divisions on the vernier scale, while the smallest reading which we can measure with the help of the vernier caliper is 1 millimeter, while the number of divisions on the vernier scale are 10. So we can get the least count of the vernier caliper as 0.1 millimeter, or which is also equal to 0.01 centimeter. Now we will discuss about the zero error and the zero correction. If we close the jaws of the vernier caliper gently and the zero line of the main scale coincides with the zero line of the Vernier scale, it means there is no zero error, or the zero error is just simply 0. Error will exist either if the Vernier scale is towards the left or towards the right side of the main scale. The error will be negative if the 0 of the Vernier scale is towards the left of the 0 of the main scale while the jaws are gently closed. And the 0 error will be positive if the 0 of the Vernier scale is towards the right side of the 0 of the main scale. Now we will see how to find out the error in the Vernier caliper and how we can do the corrections in our final result. So first of all, if the jaws are closed and the 0 of the Vernier scale is towards the right side of the 0 of the main scale, then we can say that the error is positive. And to find out the amount of error, we must have to see which line, which division of the Vernier scale is coinciding with any one division of the main scale. So now if we look at the figure, 0 is not coinciding, 1 is not coinciding, not 2, 3, 4, 5, 6. Yes, the 7th division coincides with one of the main scale division. So, by multiplying this 7th division with the least count of the Vernier caliper, the least count of the Vernier caliper is 0.01 centimeter. So we get the Vernier scale reading as 0.07. And in this case, if the main scale reading is just 0, so if you add 0 by the Vernier scale division, which is 0.07 centimeter, so the error comes out to be plus 0.07 centimeter. And for the correction, we must have to subtract this value from our final answer after the measurement of the length of any object. Now we will see how to find out the negative 0 error. The error will be negative if the 0 of the Vernier scale is towards the left of the 0 of the main scale. In this case, we always add the Vernier scale reading to the negative of the 0.1 main scale reading, since the 0 of the Vernier scale is towards the left side of the main scale. So now in this case again we have to see which division is coinciding with any one of the main scale division, and in this case this division is 9th instead of the 8th. So dear students, kindly make the correction in your book. This figure is taken from your book and you have to correct it to 9. It's not the 8th division. So if the division is 9 and you multiply this 9th division to the least count of the Vernier caliper, which is 0.1 centimeter, so the error comes out to be not the error, but the Vernier scale reading comes out to be 0.09 centimeter. And when you add 0.09 to minus 0.1, your 0 error will come out to be minus 0.01 centimeter. And since the error is negative, you must have to add that error in your final result to get the accurate reading. Now look at another figure. Again, in the figure A, since the two zeros of the main scale and the vernier scale are coinciding with each other, so we can say that there is no zero error. And the error is positive if the zero of the vernier scale is towards the right side of the main scale. And now in this case, the division which coincides with one of the main scale division is 8. So the error come out to be 0.08 centimeter. And in this figure, since the zero of the vernier scale is towards the left, so the error will be negative. And now in this case, 1, 2, 3 and 4th division coincides with one of the main scale reading. So the vernier scale reading will be 0.04 centimeter, and when you add this reading to the minus 0.1 centimeter, so our error will come out to be minus 0.06 centimeter. And for the positive zero error, the correction will be negative, and for negative zero error, the correction will be positive. Now we will see how to take measurement by using the vernier calipers. First of all, we must have to grip the object gently using the outside jaws, the external jaws of the vernier caliper if we are supposed to measure the external diameter of the object. So then the next step is to read the main scale reading. Now how we can read the main scale reading? We have to consider the main scale reading just at the left of the vernier scale 0. In this case, the main scale reading is 3.1 centimeter, or in terms of millimeter it is 31 millimeter. Then the third step is to find out the number of division of the vernier scale that coincides with any one of the division of the main scale. And in this case, 1, 2, 3 and 4th. The 4th division is coinciding with one of the main scale division, so the vernier scale reading will come out to be 4. And if you multiply this with the least count, which is 0.01 centimeter or 0.1 millimeter, so the reading will be 0.4 millimeter or 0.04 centimeter. And this reading has to be added to the reading of the main scale to find out this extra distance covered by the vernier scale division. So the fourth step is to find out the diameter by adding the main scale reading to the vernier scale reading. If we take the main scale reading in millimeters, our vernier scale reading must also be considered in terms of millimeter. The units has to be similar. So if the main scale reading is 31 millimeter, so we are going to add 0.4 millimeter vernier scale division, and the total diameter of the ball bearing will come out to be 31.4 millimeter. So this is how we can measure the diameter, the length of any object by using the vernier calipers. So now let's see one another example. Any object that is placed between the external jaws, the first step is to measure the main scale reading. In this case, just towards the left of the vernier scale 0, the main scale reading is 10.1 centimeter or 11 millimeter. Then the next step is to measure the vernier scale reading, and the number of division that coincides with any one of the division of the main scale is 7. Since we are taking the main scale reading in terms of millimeter, so we multiply this vernier scale division to the least count of the vernier caliper in terms of the millimeter, which comes out to be 0.7 millimeter. And we will get our final answer by adding the main scale reading to the Vernier scale reading, which comes out to be 11.7 millimeter. Now, dear students, there are some of the questions from your book as your homework. Question number 1.7, which is what is meant by the Vernier constant. Question number 1.8, what do you understand by the zero error of the measuring instrument? Question number 1.9 is why is the use of zero error necessary in our measuring instrument? Thank you so much. That's all for today. I hope you understood the topic, and still if you have any kind of queries, you can write your question in the comment section below. See you in the next lecture with a new topic. Till then, take care of yourself, study well, and Allah Hafiz.